of our gas law part 3. Remember last class we talked about Charles' law and Boyle's law, where we stated that Charles' law states that the volume of a fixed mass of gas is directly proportional to the temperature, provided that the pressure remains constant. And then for Boyle's law, we said the volume of a fixed mass of gas is inversely proportional to the pressure, provided the temperature remains constant. Today, we will be talking about the general gas equation. Remember, when we are dealing with gas law or gas equations, there are 3 variables or parameters that we must take cognizance of. And one of them is volume. And number 2 is temperature. And number 3 is pressure. While the last one, number 4, is motion. When we are done with the Boyle's law and the Charles' law, these 2 laws came together to give rise to another gas equation, which is called the general gas equation. General gas equation. How did we arrive to this equation? Remember, I said in Charles' law, the volume of a fixed mass of gas is directly proportional to the temperature. This is for Charles' law. And then for Boyle's law, we said the volume of a fixed mass of gas is inversely proportional to the pressure. This is for Boyle's law. Now, the combination of Charles' law and Boyle's law gives rise to the general gas equation. Now, I'm going to combine these 2 equations so we can arrive at a particular final formula. Now, we're going to start with Boyle's law. Let's say the volume of a fixed mass of gas is inversely proportional to the pressure. This is for Boyle's law. Now, I want to use the same volume to connect with temperature in Charles' law. Now, we're going to say the volume of a fixed mass of gas is directly proportional to the temperature in Kelvin. Now, this is for Boyle's law. Now, this to this is for Charles' law. Remember, Charles' law directly proportional, Boyle's law inversely proportional. So this part is for Boyle's law. While this and this, when you close this down, what we have is this and this. We are having what we call Charles' law. So we used our volume to connect with Boyle's law and Charles' law. Now we are going to get rid of the proportionality sign, and we are going to have our V equal to 1K over P and times my T. Next thing we are going to do is to make this look like this. V equals to KT, because this K times T is KT all over P. Now let's make K subject of formula. So we are going to have cross multiply. So we are going to have KT is equal to V and P. So what do we have now? Divided by K. Divided by the, what's the coefficient of K? T. So divide both sides by T. So T cancels this. So our final formula is now going to be K is equal to Vp over T. Now it means in general gas equation, wherever I see my K, which is the constant, it represents volume times pressure all over temperature. Now we're going to rewrite it. Volume, let me start with my volume 1 and P1 all over my T1. That is for K. Is equal to my volume 2 and my P2 all over T2. So this is the formula for general gas equation. The V1 is your first volume. Your P1 is your first pressure. Your T1 is your first temperature. And don't forget, your temperature must always be in Kelvin. And then the V2 is the new volume when either the temperature has increased or decreased. And then where pressure has increased or decreased. Now we are going to use this to solve simple questions. A gas with pressure of 1.86 atm, volume of 3.3 liters, and a temperature of 20 degrees Celsius. If the temperature is reduced to 14 degrees Celsius and decreases the volume to 2.5 liters, what will the pressure be? Now in this question, how do I know the formula to use? When you see your variables or parameters in the question involving volume, temperature, and pressure, then the right formula or equation to use is general gas equation, which is P1 V1 all over T1 equals to P2 V2 all over T2. Now, in this case, let's write down our variables. We have my P1. From the question here, my P1 is 1.86 ATM. And what is my V1? My V1 is 3.3 liters. And what is my T1? My T1 is 20 degrees Celsius. But remember, we don't use Celsius. We use Kelvin. So I'm going to use plus 273 to convert my 20 degrees Celsius into Kelvin. And 20 plus 273 will give me 293 Kelvin. Now, the next thing to do, we check for the other variables or parameters given to us. We have our V2. V2 is 2.5 liters. And then we have our temperature 2, which is equal to 14 degrees Celsius. 14 degrees Celsius. So it is in Celsius also. So what we have to do is to convert my 14 degrees Celsius to Kelvin by doing plus 273. And what will my answer be? My answer will be 297. So my temperature 2, which is 14 degrees Celsius, we have to convert it to Kelvin by doing 14 plus 273, and my answer is 287 Kelvin. Now we are going to connect them and substitute them into our general gas equation formula. So what is my P1? Remember, in this case, we are looking for the pressure 2. We are looking for the pressure 2. Now we are going to substitute our values. We're going to have our P1, which is 1.86, multiplied by my V1. My V1 is 3.3. All over my T1. My T1 is 293, equal to my P2 is unknown. That's what we're looking for. Don't forget that. And then my V2 is equal to, my V2 is 2.5. What is my T2? And my T2 is equal to 287. Now, what we have on the board, we should be able to make P2 as our subject of formula. We have to cross multiply. And then we're going to have 293 multiplied by 2.5 multiplied by P2 equal to cross multiply 1.86 times 3.3 times 287. Now let's press this to know what 1761.606. So we're going to divide which side by 7. We're going to divide by 732.5. 732.5. Let me make this purpose. Divide by the coefficient of P2, and that is going to be, oh sorry, I'm running short of 8. So we are going to have our 732.5 equal to this. So we divide by the coefficient of P, and that is 732.5. So this cancels this. So our answer for P2 is going to be this divided 2.4049, or we can say 2.4015 ATM. That is my answer. Now, when you have solved for general gas equation, there are some parts that might be a little bit tricky for students. How does this question come? Sometimes you may be given your volume 1, your pressure 1, and your temperature 1, and you will be asked to solve for the new volume at STP. Now, how do we solve questions like that? When we already have our P1, V1, and T1, and now we are asked to solve for the V2 without giving us any P2 and T2. But remember, you were asked to solve your V2 at STP. What is the meaning of STP? The meaning of STP stands for standard temperature and pressure. And in our gas law, whenever you are asked to solve at STP, all you have to do is to write down your temperature, standard temperature, which is always 273. And your pressure, which is always going to be at 1 atm or 760 millimeter mercury, depending on the unit of pressure given to you. Now let's take, for instance, you have the volume of a gas to be 20 cm3 at a temperature of 40 degrees Celsius and a pressure of 600 millimeter mercury. Calculate the new pressure, calculate the new volume at STP. Now, here is the question on the board. We have our volume 20 cm3, that's my volume 1, temperature 40 degrees Celsius, and my pressure is 600 millimeter mercury. Now we are asked to solve for the new volume at STP. Remember, at STP, temperature is 273. And pressure, in this case, we are giving our pressure to be in this unit, millimeter mercury. So the standard pressure with a unit of millimeter mercury is 760 millimeter mercury. So don't expect your teacher to give you your temperature too when you are asked to solve at STP. Do not expect them to give you your temperature or your pressure. Do not expect that. Once you hear at STP, it means the temperature at that point is 273, and the pressure at that point, depending on the initial pressure given to you, the unit, if it is in millimeter mercury, it is 760 millimeter mercury. Now, let's solve this question. So we go with our general gas equation, which is P1 V1 over T1, which is equal to what? P2 V2 over T2. Now, what do we do in this case? My P1 has been given as 600, and my V1 is 20. So what is my T1? My T1 is 40 degrees Celsius, but we have to convert it to Kelvin, so we do 273, and we are going to have 313. It's going to be 313 Kelvin. So we are going to have our P2, which is now going to be an STP. Our P2 is an STP, which is 760. Remember, your teacher won't give you this. You should know. If you see 600 millimeter mercury and you want to get your pressure to an STP, your STP for pressure is going to be 760 millimeter mercury times the volume, which is what you're looking for. The volume is what we're looking for. So unknown. And what is my temperature 2? My temperature 2 is 273. Standard temperature is always 273. Now you cross multiply. Please, I want you guys to give me my answer on the comment section. Thank you very much for being part of this